So, good day. My name is Abraham M. Venus, a fourth year civil engineering student, section B, and today I will be discussing about earthquake engineering, which is the response spectrum analysis or RSA. So, spectrum analysis using almost same principle as time history analysis, but only instead of finding time history, we will find the maximum values of the response. So we will perform a process on a 10-story building and we will base it on NECP 2015. So the first thing we do is compute the mass or M and stiffness K in each story. So since the stiffness and the mass are already given by Sir Olivo, so the next is we will calculate the eigenvalues. So, but as what you can see, the eigenvalues are already been calculated. So, after we solve this equation, the roots will be this. So, the mode 1 is 32, mode 2 is 284, so on and so forth. So, we have to remember that the order is from lower to higher value. So, the lower is in the mode 1 and the higher is in the mode 10. So we have the eigenvalues for every mode from mode 1 to mode 10. So here is the eigenvalues. So to solve the modal frequency, all you have to do is square root every mode. So this is modal frequency. So square root the every mode. So and once you have the values on your modal frequency, just solve the modal period using this formula, the 2 pi over modal frequency. So so but as you can see, uh, we cannot solve this because all the values here are zero. So assume that the phi tenth is equals to 1. So in order to solve this problem, we need to remove the last row. So here we will remove the last row and transpose the 10th column. So the negative 1511 will become positive. So the 9 by 9 is to be multiplied to the transpose column to get the mode shape. So this is the result. So as a result, we have here the values and getting the mode shape for mode 6 to mode 10. So here is the results from all mode shape. So we have here the modal participation factor. So we have here L is equals to transpose of mode shape matrix times mass matrix times directional displacement unit vector. So and um, generalized mass matrix equals transpose of mode shape matrix times mass matrix um, times mode shape matrix. So in computing L and in computing L we have L is equals to transpose of mode shape matrix times mass matrix times directional displacement unit vector. So we have here the original value of our phi or mode shape matrix, and we will transpose it to the Excel using Excel. So once you finish it, multiply it in M or mass matrix. So this will give you this result. So transpose of mode shape matrix times mass matrix. Uh, so so in it will multiply into D with the value of 1 from mode 1 to 10. So this is the result we get earlier. So we will multiply it by D. So and it will give you the L or coefficient vector. So since we already have the coefficient vector, we will now proceed to um, m hat. So this is the value we get. Uh, and using Excel, just multiply it and you will arrive in these corresponding values. So inverse generalized mass matrix. So you can inverse m hat in Excel by typing inverse and select the corresponding matrix that you want to inverse. So this is the last part in solving the modal participation factor. So we already have all the value. All we need to do is multiply. So modal, let's multiply it. So that is the result. So modal mass participation percentage. So to get the modal mass participation percentage, so effective modal mass over total mass times 100%. So and for the effective modal mass, we have the formula of L Hadamard times gamma. So in getting the effective modal mass by multiplying it, we will give you this result. So all you need to do is multiply L uh, by uh, gamma times gamma. So in getting the M total, we need to add all the values from mode 1 to mode 10 to get this result. So to get the modal mass participation percentage, the value of effective modal mass, divide it to the value we get earlier times 100 to get the percentage. So determining the corresponding spectral acceleration. So we will use the spectrum curve. So which is CA is equals to 0.44, CV is equals to 0.64, and G is equals to 9.81. So in solving the TS, so the value of CV, which is 0.64, divide 2.5 times the value of CA, which is 0.44. So the results will be 0.51818. So 0.2 times TS, so which is 0.51818, so is equals to 0.11636. So spectral acceleration. So here find the suited in um, three conditions. We have here three formulas. So from T1 to T10. So you must find a suited one here. After you find their values in three condition, multiply them by G, by the values of G, which is 9.81. So this is will be their results. So this determining the spectral displacement. So first, squared each values here. So, and divide the spectral acceleration values by divide it by modal frequency values. So after we squared earlier, so it will give you these results from spectral displacement and convert the unit into millimeter. Just multiply it by 1000. So to get the modal lateral force, so using this formula and our results earlier, uh, the gamma times spectral acceleration times mass matrix and the eigenvector from the model 1 to mode 1 to mode 10 rather. And here is the process to get the F1 to F10 and also their answers. And we have here all the summaries of all lateral force. So compute the modal response modal story shear force. So we have here the results using this um, formula for F1 to F10 to get their modal story shear force. So by using this formula, we will get these results. So the process is still the same. We have to get the modal story displacement, just multiply these three using this formula. So all the modal shield force of floor 1 from mode 10. So add it. Um, all you have to do is square root their sum here and the results we with this peak story share. So peak story displacement. So the displacement here is 7 here. So peak story shear. So the displacement. So the displacement here. So the displacement here is 17. Here is 54, and here is 80, 88, and so on and so forth. So peak story drips. So using this formula, we have delta peak 1 uh, displacement of m peak 1 minus displacement of m peak 1. So displacement of m displacement of m is equals to 0.7 r displacement peak. So r is equals to 8.5. So we have here the value of peak drip story using um, this formula. So So I forgot to include since t is equals to 1.110727, so is greater than 0.7 sec. Therefore, story drifts must not exceed 0.020 times the story height. So delta mix is equals to 0.020. So ito S max is equals to 0.020 times 3,000 millimeter is equals to 60 mm. So therefore, we will use 60 mm for the displacement value of this peak 1 to 9, and for the 10, since it is less than 60, therefore the drift values remain. So so this is this is how we visualize. So the peak one, the values is greater than 60. So we will put 60 from 1 to 9, and while the 10th floor remains the value of 34.22904.